the first talk this morning was more about AI, ethics in AI or artificial intelligence. And the next talk will be more focused on IA or information architecture. And as we say regularly, there is no AI without IA. So there is a very strong link between the two topics. The next speaker is one of the most prominent women in IBM. She is a distinguished engineer, a master inventor, a fellow at the Royal Academy of Engineering, and a tireless mentor for women. She is also a trusted advisor to large companies, working with them to develop their data strategy and data governance. Recently, she has been leading ODPI Egeria, one of the most strategic open source projects in IBM about data governance and information architecture. The goal of Egeria is to help and to ensure that organizations all around the world are keeping our data safe and using it appropriately, making our lives at the end of the day as data scientists and data practitioners easier. So please join me in welcoming Mandy Chessell. Mandy, please.
Thank you very much. Shall I share the charts, or are you going to share them from your end?
I think Brian will share the slides for you.
Fair enough, fair enough. So thank you, Sarah, for that lovely introduction. Yeah, so this topic really has two parts to it. One of them is to give you a little bit of an understanding of what's going on behind the scenes to supply data to you in your work. And then secondly, to look at how you can help in making that job easier, because you'll see that this is a hugely complex environment, far too complex for a human to analyze and understand. I think they're coming up, that's excellent. And also an area where that complexity, I mean, when things go wrong, we need to be able to react very fast. And again, this is where AI and machine learning is going to be very valuable. So I'm going to talk about these topics, and I think we're nearly ready to go. You want to go on screen saving? That's excellent. So let's move on. I put, that's just a little bit about me, which Sarah's covered beautifully. I think that the only other extra thing is that I've been in the industry over 30 years, and so seeing huge change. And this change is actually one of the major reasons behind what I'm going to talk about. So we'll come on to that in a little bit more detail. So let's go on to the agenda, which is chart 4. Yeah. Okay, so as I said, 3 parts. We're going to talk a little bit about modern data landscapes and what actually is going on behind the scenes. We're going to talk about Egeria, which Sarah mentioned, and this is the work that we're doing in open source to create a knowledge base for data science about the data architecture. And then talk about some of the interesting challenges I see in this ecosystem where it would be wonderful to get some help. Okay, next chart, please. So I thought I'd start with a very simple thing, and for you, you're probably going, this is just crazy, no one would do this, but it helps to start to illustrate the way that data scientists work to people who aren't necessarily data scientists. So here we've got Callie, she's a data scientist. She's combining data from 2 different sources, one from inside the company, public data, she thinks that's fine, and also some data from an external site. And she brings them together and creates what she calls a birthday card service, which basically sends people an email on their birthdays. So if we go to the next chart, so the 2 problems with this. One problem is very related to the first talk, which is the work she's doing with this personal data is probably not that ethical, even though it's all public. You know, so it's not about the confidentiality of the data, it's the use that matters. And the second thing is that it actually didn't work. And it didn't work for a very simple reason, in that she thought the date there that was in the data was a date of birth. it was actually the data registration. So it's 2 or 3 days out, maybe a little bit more. And this happens quite often, not with such a simple example, but when you're looking at data from a company, its profitability, is that before or after tax? Is that for a month? Is that for a year? All of this information is critical to actually processing the data successfully. And this is what most data scientists spend a huge amount of time trying to find out what the data that they're working with really means. So next chart, please. The problem is that the person who knows is a long way away from the data scientist organizationally. So they probably work in the operational team. They are using the application that's actually generating the thing. And they have lots of secret little codes that they use in the data because it's a lot cheaper for them to do tricks with the data than actually have the application upgraded. So some examples from my customers. One customer was using the 5th line of the address for messages for the postman, like leave the parcel behind the gate. And the reason is that the application didn't have something for the postman, and the address was printed on the envelope, so it was there available as for the letter. So you get a lot of additional things happening in the data that only the people who use the system that created it actually understand behind it. So we have to somehow bring these people together, not necessarily in a personal conversation, but we need a way of capturing the knowledge of the data expert so that the data scientist can pick that up. If we go on to the next chart. The other problem that we often see is that here we've got some payroll data, which HR is somewhat reluctant to share. So if we go on to the next piece. The reason is that in there includes both the salary and the bonus for the year. And if we continue on to the build, Callie is, she's an employee, so she's actually in this data. And I think if you click again, it'll underline her name. And then I think there's one more to go. Yeah, so really what happens is when that data comes to her, if she doesn't need to know the salary information, we need to ensure that that is properly masked as it comes into her work area. So these are very sort of illustrations of the types of things that need to be considered when we're serving up data to data scientists. Next chart, please. Now, what I showed you was a very simple process. What's true is that we've had over 40 years of innovation in the IT industry. And rather than sort of every few years throwing all the old systems away and rewriting them with new systems, we keep bolting things on. So you imagine, it's just being added to and added to. And generally, when you bring in a new system, in order to keep it independent, it takes data from another system as a copy and then a feed. So they don't share databases. They have their own databases and data is copied. So when you look at this picture, what you can see is that the boxes are the systems and the blue lines are the data flows between the systems. Now you imagine you get data out of one of those systems. Where did it come from? What does it mean? Go back to Callie's original question, how on earth in a real environment, not just that silly little example, can you possibly know what this data means? And if something goes wrong, how on earth are you ever going to trace where the data came from? What, imagine a new piece of data going in that's actually incorrect. And this is everybody has this problem who's been around for a while, because technology has moved on and there's so many better techniques going on. So we have this constant mesh of data flows, as well as different technologies coming through. And so part of the problem that needs to be solved is how on earth do we start to simplify and understand this? So in a way that you can actually start to really make better use of the data coming out of it. Okay, next chart, please. Because the real problem is, and I'm sure many of you who are good data scientists know this, is there's no such thing as a fact. There's no such thing that is so fundamentally true, that is true in all cases. So if we think about that simple question, where do you live? You probably say, well, that is a fact. I know exactly where I live. But when you talk to different people, you give different answers. So for example, if you were on holiday in a different country, you would probably, when they said, somebody asked you, where do you live? You would give them your country. If you're talking to a neighbor, you might say, oh, I live over there, and point to your house. That's the same fact, but depending on the context in which the data was gathered, the actual numbers that were written down or the text that was written down is different. And so it's absolutely critical that you understand the context. I think we click again. I think it's a box around it. You understand the context where the data was captured, because until then you don't really know what level of precision you've got, the timeliness, etc., etc., etc. Even if it says this is where this person lives. So we stopped, or we're moving forwards. One more. There we are. That's so. So in the olden days, we used to write systems that was fairly self-contained, and there would be limited data exchange. But because of the fact that the internet came along, and rather than every policy we have with an insurance company, every account we have with a bank are no longer separate entities, we expect to be log on as ourselves and see all the products that we've bought from that particular company. So the company is forced to create these integrations between the systems, and the data flows started. The other thing is that regulations require an organization to demonstrate that they're behaving correctly and legally. And so they have to show that not only that the report that they produce is correct, but that the working out is correct as well. And that actually means that they need to be able to explain where the data came from. However, in order to do all these things, for data science particularly, we take the data out of its original system. And I say it's like a tortoise that's had its shell taken off. So when the data is in the application, it's totally protected by the services of that application. So that controls who can access it, how it's displayed, all the functions that run on it. And then we take it out, and it's completely vulnerable. So what we're working on doing is creating a shell for the data as it moves into these new environments, so that it's protected. Next chart, please. Because when you start to look at it, what is at stake is so much of the business's brand, their financial performance, their service to their customers, etc. if we get this data piece wrong. And so the information architecture, pulling on from the first talk when we were talking about the ethics of the actual analytics, there's a huge amount of ethics that's actually embedded in the flow of data and the logic that flows the data between the systems and delivers it to the data science on the model and the AI itself. And then when that's deployed into the real environment, we've got questions about what's feeding it at in the runtime, and also how those results are being used. And all of these affect the performance of the organization that's using this technology. Okay, next chart, please. So we've talked about the environment, very complex, lots of people involved, too complex for an individual. So let's talk a little bit about Egeria, which is the project that I work on, which is actually around building a knowledge base of what's going on in the systems and their integration, so that it can be manipulated, automated, and ultimately have things like machine learning applied to it to help us poor humans manage this ecosystem effectively. Okay, next chart, please. So what we're talking about is building a catalog. You might hear the term data catalog, metadata catalog, but a service that would bring all knowledge about the data that's being used for a data scientist to their tools. So not necessarily having to go to a different place, but basically they can say, I want to look at this database, and you'd know everything from what it's about, all the assumptions, the context it was gathered in, you know, when it was last updated, how confidential it is, its structure, etc., etc., etc. This is the goal from a sort of consumer perspective. Next chart, please. And so you think about, where is an example of this working well? And the place that's really got this right is our digital photographs. Basically, if you remember, before we had digital photographs, you basically printed photographs on paper, and it might have the date on it, probably didn't, and you had to write on it exactly what the photograph was. But nowadays, with a digital camera, whether it's on your phone or it's a dedicated camera, it captures a lot of information for you, and this is metadata. So here we've got information about what the phone was, what the settings of the camera was, where it was, the date, time, etc. So this is extremely valuable information that it's actually standardized and embedded in the data. It means that although this was taken on an Apple iPhone, as you can see, I could actually use an Adobe product to read the metadata. And from a data science point of view, it is then now possible to take photographs from different cameras taken at different times of the same location and actually start to see what's happening in that area. And the metadata helps the machine learning to modify, what it's seeing in quotes in the photograph. So this metadata helps us catalog, helps us understand the content, and actually automate its use in different cases. So very good. The problem we have is that there are hundreds of metadata standards, all for different types of data. They don't cover everything we need to do to manage our information architecture, and they're all different. So we have lots of standards, and we need to somehow bring them together into an ecosystem. Also, most business data doesn't have metadata embedded. So that's another, we've got this big gap as well. So if we go on. Now, this is a paper I wrote a while ago, and I thought, well, let's just look at the metadata associated with this document. And you can see that everything is wrong. What it's about, who wrote it, what company they work for, it's completely wrong. And this is the problem when you get humans to do cataloging, because we are actually really not very good at it. And in general, the person being asked to do the cataloging, the subject matter expert, gets no value from filling that information out. Filling that information out is only valuable to somebody who's downstream consuming it. So we need to avoid using human experts, except for cases where they are motivated motivated to actually get value out of it. So this is a sort of contrast between the digital photographs and the human interaction. So next chart, please. So what we're looking to do, as I said, is to give that data, our tortoise, a shell that protects it. And it's not just the knowledge of what that data means, but it's also how that data needs to be managed and governed. And that on top, and so that we can have automated processes, both managing the knowledge about that data and the data itself in a way that is reliable and auditable, so that an organization can demonstrate that they are using data legally and ethically. Okay, and automation, the cost is also a key part of it. But we can't have a world that is totally locked down or dependent on a single central database of metadata. And in the industry today, we have an awful lot of metadata catalogs. If you go onto a search engine and type metadata catalog or data catalog, you will see a huge number of organizations that offer this capability. And there are continuous startups covering this topic. The problem is that each one thinks of their solution as the center of the universe. Now, when you think about all the different places that this metadata is needed, no one single tool, no one single database is actually going to be able to support everything that's needed by an organization. So we need a more peer-to-peer, open, distributed approach to metadata management that allows individuals to use the tools they want to use, whether they're open source or from a particular vendor, doesn't matter on the source, that information should be visible and available through, as I say, through open standards. Next chart, please. So this is the sort of the traditional approach to handling this, is that we copy everything we need to know about data into a metadata repository, and then people use the interface of that metadata repository to find the data that they're interested in, and then hopefully provision it into sandboxes or wherever it needs to go. These are so good, and so many tools provide metadata repository. If we go to the next chart, what we see is that mentality that there is only one tool and it's my tool, and if you load everything in, I can do everything for you, is actually not tenable. And if we go to the next chart, what you'll see is the actual reality is that companies end up with lots of metadata tools. So each of those cylinders is a different tool with a different repository about covering a different subset of the data. Because the content is driven by the users of that tool. So if you've got users that are focused on a small set of systems, then that tool will know about those systems. It won't know about the other systems, and the knowledge that these users provide around those, that they gather around that particular set of data sources is not shared with anybody else. So we are creating silos of metadata in exactly the same way as we create silos of data that makes the data scientist job so hard. So we need to work out how we're going to improve this. As I said, the answer isn't a single centralized database that everybody uses. If you go to the next chart, what we actually need is for these tools to maintain their own repositories just in the way that they do, but there is a open architected sharing mechanism that's available between to allow these products to share with integrity. So, if we're going to start securing data, managing, governing it, and allowing data science to make decisions on it using this metadata, then this metadata better be correct. The more we use it, the more important it is. So data integrity or metadata integrity is absolutely critical in this environment. So the reason that this is an open source project is that it has to be, it has to be open because we need multiple vendors to buy into the ecosystem. It has to be peer-to-peer. There's no central control. There's no one vendor taking over this ecosystem. And the distributed peer-to-peer nature also means it's scalable, because you have as many tools as you have communities of people working on their tools, and the infrastructure behind it is horizontally scalable. It's not relying, there's no single central point of failure in the middle of this. It is literally peer-to-peer, and each tool operates and does what it does best, but they're sharing as well. So if we go on to the next chart. So this is a sort of, 30,000 foot view of what Egeria is doing. So you think of all the different types of tools that work with data, that manage systems, that take data from development into production, that provide support to business users, etc. All of these different types of tools store metadata in some form, or could help their organizations with all of these tools could also benefit their users if they have this metadata provided. So we're not just thinking about data science tools, we're not just thinking about metadata repositories, we're thinking about all tools in all parts of the software development lifecycle, the business operations and the governance operations of the organization. So let's go on, or do we need to pause for a question? I just noticed one pop up.
Yeah, I had a question, Mandy, a very general question. So you mentioned very well how the current information architecture is really fragmented and difficult to monitor. I was wondering if, or how do companies, big companies with very big legacy systems, adhere and to this new paradigm of federated and distributed management versus the centralized and very rigid paradigm that we used to have in the past years. Yeah.
Yeah. So I think there's two parts to this. There's the federated and integrated data landscape and the federated and integrated metadata landscape. And to be honest, most organizations are still in the, I've got a new project, I'm going to copy all the data I need and I'm going to create a new environment. And that is an ongoing philosophy that is an illustration that actually it's very, very hard to do anything else. And then organizations go through a rationalization process where they take, where they use new technology to build a new piece. So for most organizations, it's a question of just creating something new that sits on the front of the original pieces. Where we see companies being more successful, particularly around metadata management, or maybe the one follows on from the other, that when an organization decides they want to become more data driven, the organization needs to start to morph to be much flatter and with a lot of lateral communication, because data needs to flow laterally rather than up and down the traditional pyramid hierarchy. And as they do that, they start to realize that they need to share knowledge about data as well as the data itself. And that's when the idea of a distributed metadata function starts to become very appealing. So any company that has a very distributed rather than centralized management style, or one that is laterally communicating and managing data because they're very data focused, see this as the most natural way to operate. Where you've got an organization that's really not data driven and is very control focused around business function, then typically each team buys their own metadata product and they use their own tools, but there's very little sharing between them. And so the sort of more traditional unconnected tools are found in those parts of the organization.
Okay.
Did I answer your question?
Yeah. Do you mean, Mandy, that the adoption of AI, machine learning, and more recently the GDPR and the ethical issues and questions raised by our machine learning pipelines and applications, could they be an accelerator for the adoption of this kind of?
Absolutely. Because things like AI and GDPR are on the agenda of the board, suddenly there's an opening for the CIO or the chief data officer, whichever one you have, or both, to actually say, we need to think more carefully about our data. We need to invest in our data. We can't just keep investing in function. We need to invest in our data architecture that sits behind and integrates the applications within the organization. So it's the fact it goes onto the board agenda means that there's an opportunity to explain these issues and create investment. Maybe that's the right word.
Mm-hmm. Okay, clear. Thank you.
Okay. All right. So let's keep going. Next chart. So back to the real world. Nice fluffy cloud beforehand, but actually what's going on is that the applications and the data is coming from an increasingly wide variety of systems. So we could be right down to devices sitting in factories and different locations and carrying around with us, like in our cars and things like that. It's gathering information. We've got traditional applications, we've got mobile applications and other devices, all collecting data that may then be brought into a data lake and then served up for new use cases as well. Plus also we have to remember that data doesn't all come from our own organizations, it comes from partners as well. So if we go to the next chart, this is what we're trying to do with Egeria. Now what you realize is that Egeria itself has to go to where the metadata is. So we deploy Egeria into each of the operating environments, and then it communicates with itself effectively to create that peer-to-peer exchange. So each organization, each system that comes into the ecosystem deploys their version of Egeria, and connects up. And then it starts to become part of the bigger sharing issue, capability. And there's sort of a asynchronous replication going on that the other members can subscribe to and receive metadata. There's also a federated query. So as a member joins, everybody else updates their federation configuration automatically. And that means that the new member is now included in queries to find things. And we'll talk a little bit later about why that's so important to have both a replication mechanism and a federated query mechanism in order to create performance for all use cases. Okay, next chart, please. So if you go to our website, you'll see this picture. And this picture really is showing, you imagine the big fluffy cloud I had first, and all those tools are sitting in the grey boxes. And they're all sitting in different environments. So we put the Egeria platform into each of the, maybe their cloud platforms, maybe their data centers for the organization. And then we start to deploy our servers, and each server manages the integration of a particular tool. And Egeria behind the scenes does the magic to enable the sharing. So that's that technology, and so what you can start to imagine is we have a very oh no, it's got two more charts to go before we get onto that. The next chart shows the scope of the metadata that we're collecting. So what you can see here is that there's information about the data assets, which could be that photograph. Could be a document, could be a database, set of database tables, files, etc. Whatever you're thinking, that's the data assets, including APIs and data feeds and things like that. A glossary adds semantic information, so we start to understand the meaning of things. Governance provides the rules around how that data can be used. Think of it as terms and conditions, classifications, policies, etc. Lineage tells us where things have come from a business and technical perspective. Base systems, base types infrastructure. This is so that we know where data is and how it's supported. So we can validate that personal data is on an encrypted device, is maintaining data sovereignty, there's a good chance of availability, all of those things that are necessary in order to keep data safe. And that's really the yellow area. Collaboration, this is the feedback from people who are using the data, their experiences, the things they've noticed wrong, and this allows conversations between different users as well as the actual original owner of the data itself. Models and reference data set standards, define valid values, and the metadata discovery is actually where the data science comes in. This is an area where annotations and additional information that's come from analyzing the data and the infrastructure around it is actually stored and attached. And we keep it separate to say this is machine generated. And depending on the type of machine generated information, it may be immediately accepted into the main part of the metadata repository, or it may go through a stewardship process depending on how reliable that type of analysis is. So that's the main thing. And if we go to the next chart, you'll see the same subject areas of metadata linked together. So imagine this as a massive linked virtual graph being maintained by all the different systems. But this linkage is so important. It's this linkage that creates the insight that is completely invisible, because each tool will support a tiny subset of this whole picture. But when you query through the Egeria interfaces, it's as if they've all been brought together into a single repository. Okay, next chart.
Yeah, Mandy, perhaps we will answer a few questions.
Sure.
The first one from Helen Greenhoe: how does Egeria deal with metadata in different standards?
So we have lots of different interfaces. So we have one low-level interface that covers all types of metadata, but it's quite difficult to use, and you really need to understand the big metadata landscape. So we also have different APIs that are very specialized. This is the API for ETL engines. This is the API for data science tools, etc., etc. And they are built from combining standards in that area that are meaningful. And then on calling those interfaces, we have utilities that are able to understand specific standards. So effectively what we do is we take the standard and we map it to this central model here. And then through our interfaces, we provide support for different artifacts like OWL, JSON-LD, et cetera, relational database standards. And so we're not trying to create, we have, as I say, we have our own interfaces, but we try to embrace every standard that makes sense, because that helps with automation. It helps with our ability to reach a wide range of third-party technologies. And to be honest, the standards are built by people who really know what they're doing, and there's an awful lot of valuable information embedded in these standards. So it makes absolute sense to use them.
Okay.
Okay.
And the second question from Asel, what formal methods does Egeria use for the verification of the correct data journey within IoT devices, data lakes from this slide about open metadata systems?
Yeah, so Egeria is a knowledge base, and there are certain things it can detect, anomalies and things like that. But really, this is where the information architect comes in, the ethicists, the people who are looking at this ecosystem. So what we're trying to do is to create visibility on the environment and where the data, basically on the data architecture, so that experts and things like machine learning can start looking at this to do that verification, because the verification is not just a design verification, it's also a runtime verification. Because, for example, if you're doing a calculation based on data aggregated from multiple sources, and one of the sources goes down, there's a time window between that source going down and when the calculation runs. So to be sure that that calculation is correct, every single source has to be up and providing its data in time. So what you get is, between those flows of systems, you get time windows where, recovery time windows effectively. And so the correct pathway is not just making sure that you started with the right, pulling from the right systems, but they actually were providing all complete data, correct data at the right time for any of the calculations to happen. And this is the thing that organizations find incredibly hard to do. They have to design and think that through, and the operations team need to be completely aware of where these windows are. And you can see this is an area where machine learning is absolutely critical, really, and it's not something that we're really doing today as an industry.
Okay.
I must think the big reason is that the knowledge base is just missing. There's no data to do this properly. Okay.
Okay, clear.
Yeah.
Thank you.
Okay. All right. Next chart. Where are we? Just looking at the list. Yes. So we're now going to talk a little bit. Actually, these questions were perfectly timed, because the final section is to talk about some of the things that is going on in the data, and where you can help, basically. This is just perfect for once we get the data, then this is perfect for you. So let's go on and look at this. So remember this picture, and I talked about the fact that, how on earth, if you get data from that environment, can you even begin to be sure that it's correct, it's complete, it's the right level of precision, it's up to date? How on earth can you do that without help? And so if we can start to understand and collect information about the data, that's step one. But step two is actually to be able to analyze that and understand not just the physical flows, but the timing, the completeness and the precision from each of these. And because data is not just flowing, it's also being processed and manipulated. If we could start to understand these ecosystems, then there's a chance of detecting where there's complete, well, obviously anomalies and missing data in different paths, but also where we could do some serious rationalization in this environment. So next chart, please. So one things we do as information architects is design things called information supply chains. And they're very much like product supply chains in that we think about data coming from raw materials, so different systems, and being transformed and processed along a supply chain. And particularly where we have something that's going for a regulatory report or customer satisfaction, something that is critical to the business's brand, we manage that flow as an information supply chain. And so if we go to the next chart, what you can see when you start to understand and unpick that mess and you start to see these supply chains is you can very quickly see that if you've got the user on the right hand side, it's got two reports and they're different values. You look at the supply chain, you can see exactly why there are different values, because one of them is only taking data from one of the feeds, whereas the other one is aggregating data from all of them. So this is the type of visibility and analysis that we really need to get into our supply chain so that we can distinguish why data that seems to be coming from the same place is giving, or seems to be data about the same thing, is giving very different values. Next chart, please. The other thing is that information architecture is entirely driven by non-functional requirements. So earlier on, I said that that Egeria uses both replication and federated queries. And the reason is that metadata is actually very varied in terms of how fast it's changing and how much it is. And so whenever we are building an information architecture, we're constantly trying to decide, do we access the data in its original location or do we make a copy? And there's no right answer because it entirely depends on all those things at the bottom of the chart, which are non-functional requirements. So if you've got a huge amount of data, you can't copy it. If it's changing rapidly, it would be very expensive to constantly copy all the changes all the time. However, if the structure of the data is completely wrong for the way that you're processing it, and you don't copy and reformat, then you're constantly reformatting exactly the same values. And that's crazy if the values are the same. So there is no right answer. There are people who have opinions, but there is no right answer. It's always dependent on non-functionals. The problem we have is that non-functionals change. So we might lock our information architecture down onto a particular technology that is either copying or federating. But actually what is really needed is a constant analysis of the performance and the query and the type of things going on in order to switch between, should we copy or should we query? And this is another area where generally we have two completely independent technology stacks for the two approaches, and you make a decision at architectural design time. Whereas with a little bit of machine learning and an integrated stack, we actually could have data platforms that are much more performant because they're able to make choices, the non-functional requirement choices at runtime while things are running. So that's another interesting project, probably a research project, I think. Okay, next chart, please. The next is the fun and games of matching data. So imagine that these are a record from 3 different databases about the same person. Now, the problem we have is that we don't have a serial number. We don't have a unique UUID effectively. We have lots of different identifiers that have different scopes and different and last for different amounts of time. So, for example, a lot of companies use email addresses as people's identifiers. That is something that changes very rapidly. Most people change their email address quite frequently. And so you end up with fragmented data. So it's very hard to match somebody who's changed their email address. We have other places where the information about the individual is tied to a transaction, like an order. And finally, you might have things that are like a credit card number or whatever, so more account-based identity. So different ways of identifying people that have different scopes. The other thing is that data is not always really matching. So there's subtle differences in the way our names are spelt and the way addresses are formatted, and all the things that should be easy to match are not. So there's a lot of work gone in the past on matching data, but it needs reference data sources and other things to do, and it's still a very rich area that's needed in so many places to make it possible to match and then sort of organize and correct the data across the landscape. So there's another one. And if we go on to the next chart, really what we need to do is to start understanding all the different identities. And this sort of constant thing, often this is called master data management when it's about people or products or, you know, sort of noun type data. But it's actually a really complex problem. It's not something, it is something that actually could benefit from a bit of data science around this matching and collating. And then with this type of structure, then obviously you can start to pull data from many different places. Next chart. Of course, when we're matching data, this is where it starts to get very tricky. So for example, different sources might have different subsets of the attributes. They might cover different subsets. You might have one that covers the whole country, the other that covers a region. And so again, matching based on different levels of completeness is also tricky. So we've got scope of the data, how many records do we have and what's the scope of those records. We've got the coverage in terms of what attributes are defined, and then there are the other things about timeliness, quality and things. And again, this is one of the things that makes this data integration much, much harder. And if we go to the next chart, the next click, and again, yes, what you see here is the different types of processing that's going on inside the information landscape to actually make this work. And we have, as I say, we have a long history of trying to do this with different analytical processes, but there's huge room for improvement. We'll go to the next chart. And this just sort of give you the types of problems that we have. So you imagine you've got a record for John Smith, and you've got a record for Bath. In fact, you've got multiple records for each of these two names. One of them, John Smith, the other is Bartholomew Virgil fence post. Now, if you had two records for a person named Bartholomew Virgil fence post, you'd probably be fairly confident they're about the same person, because that's a fairly unique name. Whereas John Smith is a highly non-unique name, and you could have brothers, father, son, just people in two different places, and so it's almost impossible. So the frequency of values within the broader data set is part of the problem. Next one. Now, if we add in the date of birth and the address, that's great, because we're now starting to separate the John Smiths. So as we add data, we may be able to increase our ability to match, providing they're consistent. And next, click, and click again. But the thing we have to be careful about when we do this, is make sure that these are, we're comparing apples with apples, because these two dates could be the same date if one comes from a UK system and one comes from a US system, because the way we format dates is slightly different. So that, again, we need to bring in that metadata as well as the data in order to do the analysis. So plenty of scope there. And then the other thing is something that I've been working on more recently, which is around how the sensitivity of data changes as you add and take things away. And the interesting thing is you cannot just determine the sensibility of things by the classification of the individual elements. So here we have a data set that just has employees' country, their job level and their salary, right? There's no personal information in there. But if we add something that's actually public from a public store, which starts to identify individuals, suddenly it's gone very sensitive, because we can now see who owns what. So we have to be very careful with systems that automate the decisions about what data is available based on some very, based on the combinations and the scope of the data that we see and the precision of the data we see. And again, this is not something that can be managed by simple access control lists or even simple rules. It's something that needs a lot more complex processing to really make sure that the data that's being served up to different people, particularly where it's sort of an ad hoc data serving up service, to actually make sure that that people aren't seeing what they shouldn't see. Okay, I think we are nearly done. Yes, we're into the summary now.
Sorry, Mandy.
Yes, of course.
Before talking about the summary or going through the summary, one question from Sabrina. Great talk, Mandy. Do you think that Egeria effectively addresses some of all the FAIR principles? FAIR for findable, accessible, interchangeable, and reusable. I looked at the FAIR on the
It provides a lot of the knowledge base that supports those principles, but again, you have the human involved, and so there's always, you know, we can provide data. There's support for security and privacy around the metadata as well as the data, and in many scenarios, the metadata can be more sensitive than the data itself and tell you an awful lot more because it's effectively a summary. So yes, it supports the FAIR principles, but it's not sufficient because you also have to have the ethical aspects in the humans and the systems that are actually using it. Does that help?
Yeah. Okay. Yeah. And one probably question from my side. So as a data scientist, we do find usually ourselves faced by a dilemma. We need as accurate data as possible. But at the same time, yeah, from an ethical point of view, we do need also to take into account that persons or people do not need to or do not want to share their personal sensitive data. How does Egeria tackle this problem for regarding sensitive and confidential data? Do we have a machine learning layer that detects this kind of information and tries probably to put a layer of sensitivity or confidentiality for this particular data set?
Yeah, so we're partnering with another open source project called Palisade to actually change access based on the project and the purpose of the work. So imagine a data scientist that's working on looking at, they're doing some COVID-19 work and they're looking at patient information and they need access to personal information in terms of someone's situation in order to understand the state of spread of the disease. And then the following week, they're doing a marketing campaign to maybe the same people. But when they're doing that marketing campaign, they don't need the detailed knowledge. So when you only have access determined by the single user ID, you're going to give data scientists too much scope. And people, you can't forget things. It's very hard to forget things. But if you can sort of partition the data into, I'm doing this piece of work, yes, I got sensitive access to sensitive data, but now I'm doing something quite different and my access is changed, so I can't accidentally use the wrong data. And I'm not seeing it in the context while I do this extra different piece of work. Then it makes it easier for the data scientist to say, look, I am behaving as ethically as I can based on the range of projects that I'm working on. And so Egeria provides the knowledge base for being able to make those decisions. And then Palisade has the runtime infrastructure to serve up data and modify what an individual sees for that particular project based on the settings and the purpose of that project itself. So that's what we're working on, and you can start to see at the moment we're very simple. We have a very simple approach, but you could start to see a lot more. This is where machine learning can come in to give us a lot finer view on there's two questions: who knew this fact, and how much does this person know based on their projects and their interactions.
Okay.
Does that help? Yeah.
Thank you.
Yeah. Okay, we talked about three main things really. We've talked about how complex the systems that are providing data to data science are today. There's huge value. Hopefully the data architecture people are providing value to you in terms of delivering data. There's huge value that you can provide to us in helping us improve our data landscapes and actually manage them so that we have so much better control over what's being served and used in different types of machine learning environments. But in order to make that work, we have to provide you with a decent knowledge base, and that's really where Egeria comes in. So I think that's it. Yes, there's a little summary of Egeria and then questions, although
we do still have a few questions here. Let me see. So the first question from Anna Mackenzie. Thanks, Mandy. When trying to match data, do you prioritize getting the most matches or confidence of the match? For example, if there are two entries which look to be similar, are you treating it as more important to get the match, even if only 80% sure, or to be fully confident to avoid incorrect matches?
Yeah, right. So this is entirely based on use case. And it's again the same question as, is this data good enough quality for my use case? So let me give you some examples. Say I'm going to send out some information about an event. And if I either match or don't match somebody, the impact is that they might not find out about the event, or they might get 2 emails. It's not life-threatening. But if a patient comes into a hospital who is unconscious, and we try and match the record for their sort of admittance to hospital that time with records of other patients that seem very similar, the danger of getting that wrong is far, far higher, because we may miss medication that patient's on because we fail to match, or we may match 2 people who are different and then make the wrong decision. So in that situation, the matching has to be pretty sure, and you need to involve a medical person that's going to make that decision. Whereas in the case of the marketing or the event information, that can be automated and can be a fairly much lower level of precision. So there's no perfect answer. It's always built on the consequences of getting it wrong, and that cost will determine how confident you need to be. But the failing to match can be as dangerous as matching and merging unnecessarily, incorrectly. So you have to be very sensitive of getting it wrong in either direction.
Okay. Yeah, good. So it really depends on the use case and
absolutely. Yes, yeah, and the same thing about data quality. It's not a fixed thing. Depending on your use case, the quality may be perfectly good enough, but not good enough for something that the moment it affects people's freedom of action, their safety, security, anything that starts getting into these areas, then we have to, we start thinking like aeroplane engineers rather than people building paper aeroplanes. It's just you just have to have a completely different level of rigor when you're dealing with these 2 different cases.
Okay, and probably one brief question from my side. Could you please, Mandy, touch upon briefly the technology underlying Egeria and that enables this lineage supervision and monitoring throughout the life of data?
Yeah, so we have a lot of APIs, REST APIs that have Java and Python clients. We run in a platform that runs the different servers and that are configured for different types of tools. Those platforms can be scaled right down to run on a Raspberry Pi, or scaled up to run horizontally scaling in a Kubernetes cluster. So we can go very high scale, high reliability, right down to a very small system where we can get very close to the sensors and things in the IoT environment. So it's all written in Java, the server's written in Java, and we use all open source technology ourselves and open standards that are pretty common for for IT projects today.
That's indeed an important point. Egeria is an open source project, and it's a Linux Foundation project. So if you are interested, you can go to GitHub, download the code, look at the code. This is the power of open source.
Yeah, and the URL's at the bottom of every page.
Okay, great. I think we are running out of time, right, Leah? There are still a few questions on the Q&A box. Probably, Mandy, feel free to look at the questions and get in touch with the attendees and speak to them. So that would be easier this way.
Okay.
Thank you very much, Mandy. That was really a very interesting topic. And as I said, open source GitHub, you are really encouraged to look at the code and download it, and why not participate in this open source effort.
Thank you very much, and thank you for having me.
Thank you.
Bye-bye.
I wish there was, Mandy, I wish there was like applause buttons on Zoom. So I know it was really terrific. You were speaking to my soul as a data quality person.
Good. All right, thank you. I really appreciate it.
Great.